Hello everyone, this is Mr. Wynn, and I will be talking about slope today. Alright, slope is your rate of change. It's how things change. It's how your dependent values change as you move each independent value. And we're going to talk about how to find that with the different types of representations, right? So the first one is in an equation, the slope-intercept form. If I have the slope-intercept form, right, it's always in y equals mx plus b. Always know that your m, notice how it's being multiplied by the x, it's right next to the x, is always your slope, and b is just going to be your y-intercept. So if I had an example of y equals 7x plus 9, our slope is simply the number with the x, and the number to the side, the plus 9, whatever it is your y-intercept. Okay? Now I'm going to be talking about the slope formula. If I give you 2 points. So for example, if I give you the point 6, 8 and 7, 2, what do I do to find the slope? Well, slope again is how things are changing, right? So we're actually getting the change in y divided by the change in x, and we know how that graph is going to change, how your dependent values change for every x. So that's why your dependent values are on top, independent are on bottom. How is it changing per x? All right, and it's simple. We just put it in this formula where we subtract the y's, so y2 minus y1 divided by the x's, x2 minus x1. All right, so what I'd like to do is go ahead and label your points. So I've got x1 here, right, y1 here. All that means is it's the first x, of the first point, and then the 8 is the y of the first point. And in this case, we'll just use our 7 as x2. That's the x, the second x of the second, well, the first x, the only x of the second point, and y2, the second y of the second point. So if I fill this out, right, x1, we notice goes here, all right, y1 goes here. Notice how they're in the same column. They're subtracted second. And then x2 goes here, y2 goes here. Let's just plug things in, right? So I need y2 first. In this case, it's 2. I'm going to subtract it with our y1, which is 8, divided by, on the bottom, our x2, 7. Then I'm going to subtract it with our x1, 6, and do the math out. So 2 minus 8 would give us negative 6. 7 minus 6 would give us 1. If I divide those out, dividing by 1 is really leaves the value the same. Okay, so our slope is negative 6. That's the slope formula. What if I have a table? Well, remember, tables are just ordered pairs. They're points that's in a structured list. So in this case, we could actually use the slope formula. We just need to pick 2 points, right? So let's just use these first 2 points, right? We're going to use the first 2. We know we're going to have an x1, a y1, and then an x2, a y2. Now, really, you could use any of them because they should give you the same slope. It's changing. It's a linear function. But again, let's write that equation. So our slope form is y2 minus y1 over x2 minus x1. So if I plug things in, okay, your equation should look like this. Your y2 first, that's 2 on top, minus your y1, which is 5. All of that divided by your x2, negative 2, subtracted with, and I'm going to put this in parentheses, your x1, because it's a negative 3. I'm plugging that in, so I know it's minus a negative. And let's do the math. 2 minus 5 is negative 3 on top. Negative 2 minus a negative 3, so we're actually adding 3. Negative 2 plus 3 is 1. And again, dividing by 1 gives you the same value, so we're just going to get negative 3 as our slope. All right, how about a graph? If I give you a graph, there's a method called rise over run. If you think about it, every time you rise, you are rising up, right? So you're kind of, when you wake up in the morning, you rise up. You're counting how much you're going up over your run, which is, if you're running on flat ground, you're horizontal, right? Rise over run. So if I think about it, rising up and down is how our graph, our y's are labeled on the graph, our y-axis. And then horizontally, if I'm running, that's how the x's are, left to right. So really, it's your change in y over change in x. So graphs, if they're nicely labeled, you can just count how much am I rising by, then divided by how much I'm running by. So if I look at the first graph, you notice I am rising by, let's go from this first point on the left to the second point. I am rising by 1, 2, 3, 4. So really, our rise is 4. I'm going to divide that by our run. So our run is from here to that point is 1. And if I divide those 4 divided by 1, our slope would be 4. Now, the only thing to be careful of here is make sure your graph is actually labeled correctly. Like if I'm counting by 1, all right? We're not just counting the spaces, but notice how here the spaces are going up by 1 and the x's are being drawn by 1, okay? So looking at the other graph, if you notice, right, it's actually going up by 2. Notice our values are going up by 2. Is it 2, 4, 6, right? Same for going the y direction, 2, 4, 6. So we're actually going to be counting by 2. All right, so if I go from this point, all right, I'm actually counting down 2, 4. So your rise is actually a -4. And then I'm running 2. So I'm going to be dividing by 2. So that means -4 divided by 2, -2 as our slope. Okay, so you do got to be a little careful about how your graph is drawn and written. So rise over run, it's nice, it's easy, it's counting, but be careful of, how the x's and the y-axis and all that are labeled, okay? All right, one last one. I've got the slope in point slope form, right? The nice thing about this form is you can tell the slope straight off. You can tell where a point of it is, right? But if you see this form where you're given y minus a number and then m, right, as your slope with parentheses x minus x1, this is your point slope form, okay? Remember m from the first equation, y equals mx plus b. In this case, m here is also your slope. So if I look at the equation, just look at the number that is in front of those parentheses. It's kind of, you notice that it is kind of with the x as well, just like the slope-intercept form, but it is outside the parentheses. So right here, our slope would be 5, and I could just look at that from that equation, from the point slope form. So if you do get in this form, that number outside that parentheses, next to that x on the right side is your slope. All right, and that's it for slope. Thank you.